Hi, I'm Rich Brown with Kansas State University of Salina, and I'm going to give you a tour of the Unmanned Aircraft Systems Laboratory. Um, we are one of only 3 schools in the United States that has an undergraduate Unmanned Aircraft Systems program. There's Embry-Riddle, North Dakota, and then us, and we're the only one that offers actual UAS flight training in the sense that the other programs are 100% simulator based, and we offer our students actual UAS flight time in restricted airspace with a real UAV. This is our main trainer aircraft, really rugged. We call it the Crow, and that's what the students start off on after they go through a 20-hour scenario-based simulator training program. This is the first aircraft they fly. Another aircraft they can get time on is this. The wingtips are off right now, but this is the Penguin B. And it's our workhorse payload platform. It's got an endurance of about 6 hours. And all of our aircraft do auto takeoff, are capable of auto takeoff and auto landing, so there's no radio control flying it, providing nothing goes wrong. And they also all have what's called a lost communication feature. So if while you're flying your notebook computer freezes up or someone steps on your radio communication, the aircraft will automatically cancel its current flight plan and upload its pre-programmed lost communication flight plan. It's something that you set before takeoff. And so you can do whatever you want. We have our aircraft come back and land at the area in which they took off from. This is our flagship aircraft. This is the Mark 4.7 Aerosonde. It has a retractable gimbal camera system right there. We can do infrared or electro-optical. It also has a moving target tracking system, so we can keep the camera fixed on a particular area of interest on the ground. We don't have to continually steer the camera. We can just kind of lock it on. It's currently used by the military, but we're experimenting with using it for search and rescue purposes. It's got redundant data links, plenty of onboard power for different payloads, and it's capable of satellite communication, so you have an unlimited range on your data link if you want to set it up like that. We have it set up for line of sight radio communication out to about 10 miles.
When you say payload, what would that refer to?
The camera.
Oh, okay.
We have another version of the same aircraft that flew across the Atlantic on about 2 gallons of fuel, and it can fly for about up, depending on how much payload you put on it, up to 20 hours on about 2 gallons of fuel.
How fast can they go?
They don't go very fast. UAVs excel at jobs that what they call dull, dirty, dangerous missions. So they're not made to fly fast. That's why they all kind of look like gliders, power gliders. That's pretty much what they are. They fly about 70 miles an hour.
Okay.
And then the aircraft like this may be about 40.
Okay.
So this is electric. This trainer aircraft can stay in the air under 40 minutes. This is gas, 6 hours. The other one, much longer than that.
And the commercial applications are agriculture and...
Right, agriculture, search and rescue, of course, industrial inspection would be one.
Okay.
But this aircraft would be more typical of what you might see in the future for agricultural purposes. You want something that flies slow, low, so you can get really good high-definition multispectral imagery of your crops.
What's the future of unmanned aerial aircraft?
I think agriculture is probably the area for the largest growth potential.
Okay.
And that, a lot of people think maybe you're spraying crops. No, this is purely for precision agriculture. So you're taking pictures using different wavelengths of light, and you're able to tell through those pictures the health of the plants, so that when you spray your pesticides or lay down your fertilizer, you're only putting it in areas where it's needed, and you're not using any more than absolutely necessary.
So this will help a farmer become more efficient.
Exactly.
Very well.
See, the other aircraft we have behind you here is the UAS competition. This is a student project. It was originally a large-scale, off-the-shelf hobby helicopter, and our students took that kit and they converted it to electric. They added this landing gear, this digital video transmission system, this gimbal camera. You see we got a painted eyeball on here. And every year they go to the Student Unmanned Aircraft Systems Competition in Pax River, Maryland, and compete with other schools. There's a waypoint navigation course, also a paper, and a search area, and they use the aircraft actually to find these plywood targets. And I think they got 8th place this year, but we got number 1 in helicopter design and number 1 in safety.
And I heard that you were ranked in the top 10 for these programs internationally.
Right. This is an aircraft that we're using for agricultural purposes. This is actually started off as a hobbyist type aircraft called the Zephyr, and we added a really inexpensive open source autopilot called the ArduPilot to it, and then a modified point and shoot camera, near infrared, is that right? Near infrared filter on it. And it snaps a picture every 3 seconds. So you can throw this up in the air, fly it about 30, 40 miles an hour, back and forth, and it will take overlapping pictures. And then we have a computer program, I'm sure Mark will show you that, where he can take that imagery from the aircraft, put it in this computer program, and it will stitch all the images together to make a map. And then you geo-reference a few points in that image. And so we're able to get to 5 centimeter accuracy.
1 centimeter accuracy.
Well,
Yeah, down to 1 centimeter.
depending on how accurate GPS is. But yeah, and so we can actually tell the health of each individual plant in that farm.
Really? And with that kind of technology, it would be easy to do search and rescue if you can GPS locate within that.
Right, I'm sure, and there are lots of different software and video exploitation things, imagery exploitation tools out there that, yeah, you can use for search and rescue, or certainly there are many applications I'm sure we haven't even thought of.
And you said that the unit is called R2? Or the
The Arduino.
Arduino?
ArduPilot.
Okay.
Arduino is the software. ArduPilot's the name of the autopilot. Costs about $200.
Okay.
And it has all of the same features on it that the higher end autopilots have.
Very good.
Yeah.
All right. Come on. Stop recording.